Welcome to the Flip Classroom series, Math 9, Chapter 5.1. Teachers are Mr. Gill and Mr. McKimmon. We are trying to design a new way of doing math classes. The first lesson is a video series that you will watch at home and then come back to the school and do your practice at school. Let's begin. Math 9, Chapter 5, Introduction to Polynomials, Lesson 1, The Language of Mathematics. What is a term? A term is an expression formed from the product of numbers and or variables. Example 3b is the product of 3 and b. Remember that product is a multiplication sentence. If we look at 3b, anytime the numerical coefficient 3 is placed next to the variable b, we note that the operation that is being performed is multiplication. A term can also be a constant value. Remember, these are values that do not have a variable placed after them. What is a polynomial? Polynomial is an algebraic expression made up of terms connected by the operations of addition or subtraction. Example 3b squared minus 7 has two terms that are connected by subtraction. Okay, what are the two terms? Well, we have 3b squared is term number 1 and 7 is term number 2. And we'll note that the operation subtraction is right in between. Okay, let's look at some examples here. Name the polynomials by the number of terms. For each expression, identify the number of terms and whether it is a monomial, a binomial, a trinomial, or a polynomial. If we look at the prefixes to these words, we can start to have an understanding of what the terms mean. If we look at monomial, mono means one. Binomial is bicycle. Remember, bicycle has how many wheels? 2. Okay, so binomial has two terms. A trinomial, if we think again back to the bicycle example, a tricycle has how many wheels? 3 wheels. So a trinomial has how many terms? Well, again, that's 3. Polynomial, poly means many. So a polynomial has many terms. In this case, we're going to be looking at more than 3 terms. Okay, expression number 1. 4xy plus 3. Let's see if you can guess this as we go. How many terms does it have? It has 2. What is the name of this? Okay, we have 2 terms. Think back to the wheel analogy. Well, 2 terms, 2 wheels. It's a bicycle or a binomial. Okay, example B, 7a squared minus 2ab plus b squared has 3 terms and is a, waiting, it is a trinomial. All right, next one, 5x squared plus y squared plus z squared minus x minus 6. Number of terms, 5. Again, we have 1, 2, 3, 4, 5 terms, and it is a polynomial. Okay, last example, D, 13. Number of terms, 1. Name, monomial. All right, now we're going to look at identifying the number of terms and the degree of a polynomial. Degree of a polynomial. What is the number of terms and the degree of each polynomial? Well, we've already established that the number of terms, we can look and we can see that in 4x squared plus 3, 4x squared is the first term, 3 is the second term. So the number of terms is 2. Now, to find the degree of the polynomial, we need to start to look at the exponents. So we look and we find the variable that has the highest exponent. Oh, try that again. There we go. And the degree is 2. Okay, let's try a couple more examples here. 7a squared minus 2ab plus b squared. How many terms does it have? Here's the first one, second one, third one. Three terms. Okay, next we go to the degree. Now this is a little bit tricky because this term here has a degree of 2. This term here, we can see the exponents has a degree of 2. Now in the next one, 2ab, although the exponent is not written, it is assumed that it is 1. So the way we find the degree of this specific term is we add the exponents. So 1 plus 1 is 2. And with all three terms having a degree of 2, the degree of this polynomial is 2. Okay. C, 5x plus z minus 6. X doesn't have a variable listed, so we know that that's 1. Z has an exponent of 1. What is the number of terms? Well, here we have 1, 2, 3 terms. The degree is 1. Okay, the highest term has a degree of 1. Next, this has a constant term. Well, number of terms, well, we see only one term, but we do have a bit of a problem here because, oh my goodness, there's no variable to figure out the degree. Well, how do we have a variable in this term? Well, a variable of x to the power of 0. Remember that x to the power of 0 is 1. So that would be 7 times 1. We're left with 7. That's what we started with. Okay, so the degree in this one is 0. All right, now let's go back and we're now going to model these polynomials. We are going to model them using algebra tiles. Now remember that, sorry, I'll slide back up here. A positive tile is shaded in, a negative tile is not shaded in. So we'll see here we have the positive 1. So this would just be a constant value of 1. This one here would be a value of negative 1. The longer thin tiles, they are the x's. So an x would be shaded in. A negative x would have no shading. The next one is the x squared. So this is going to represent an x squared. Without the shading would be a negative x squared. All right, let's play. Here we have, with algebra tiles, we're going to model each polynomial. What I like to do is I like to try and set the positive tiles on top and the negative tiles on the bottom. Okay, so we're going to represent this. So we have 3x. There's 1, 2, 3x. And it's 3x plus 2, so we're now going to need 2 individual tiles. Now note, I'm putting these next to each other. They're all in the same bag. I do not need to put a plus sign in there. Okay, the fact that they're sitting beside each other will represent that it is adding 2. All right, next one, negative x squared. Okay, so now we're going to have to get the big guns out here. All right, negative x squared. Notice that the negative x squared is the one that is not shaded in. And now we're going to minus 2. Well, how do I show a minus without putting that in? Well, we just pick up our negative tiles. So there's 1, 2, and if we remember in a couple lessons from now, we're going to be talking about adding the negative. So I can also write this as negative x squared plus, and if I change the subtraction to an addition, then I have to add the opposite. So plus a negative 2, and now I've created my polynomial as a model here. Here's my negative x squared. Here are my negative 2. Let's try another example. 2x squared plus 3 minus x. So, what do we have to grab? Well, it's a positive x squared. So there's 1. Wait, here we go. 2x squared. We're going to have to add another one. Okay, there's my 2x squared plus 3. So I'm grabbing my positive 1, positive 2, positive 3. And then subtract x. So remember that this can be 3 plus a negative x is another way to write this. So we're going to grab 1 negative, 1 negative x. All right, thank you for joining us on our first flipped classroom video, 5.1. Your assignment is page 179 to 181, question numbers 5 to 26. Have a great day.